so what is a projectile right now? So what is meant by projectile? Something it is projected, right? Huh? If you throw a stone from a ground, so it is projected. Okay? So if a bullet is shot by a gun, so that is also projected, right? Some object is projected in an air. Okay, so it traces a path. That object is known as projectile. Okay, the object which is aimed, okay, to fly in an air. So that is a projectile. And then the object traces a path, right? That path is also known as trajectory. Okay, maximum the path will be like parabola. Okay, a curve. Okay, a bullet shot from a gun. Okay, if you throw a stone like this, okay, this and all, it traces a path or it traces a trajectory which is like a parabola. So what is the projectile? You know, right? What is called a projectile? This object is known as projectile which flies in an air. So that is the projectile. Is it clear for you? Okay, if you pull something in a ground, on a ground, then it may scroll or it may roll down. Okay, that is not a projectile. If the object fly in an air, so that is a projectile. Is it clear for you? So that is given. Okay, you can go through it, all these things. So far we saw like two components. What are the two components? X component and Y component. Only two dimensions we are talking about. This lesson dealt with plane. Plane means 2D. Okay, so X and Y you are taking. So here also we are going to study about all these things in a proper way. There are two types of projectile motion, oblique and then complete. We will see like. See, we shall assume that the air resistance has negligible effect. So if you throw something or if an object is falling from a height of a building, top of a building, okay, see there are two types of things we need to discuss. Suppose if it is a tower, okay, so here from a tower, if you throw a ball from a height of a tower, it is half projectile, right? It is half trajectory, we can say. Suppose if you throw a ball from the origin here, you can fix this as an origin, okay? So a person is standing here and throwing a ball, and then it traces a path, total, full projection. It reaches here, right? It hits the ground here. So this will cover the maximum range, okay, and then it is also known as a parabola, okay, it is the trajectory which is full, we can say. So these two cases we are going to discuss with. So what here we are going to assume, so when the ball or an object fly in an air, the air resistance, wind resistance must be there, right? Okay, if it is fly in an air, then we are neglecting that air resistance, right? Okay, if there is air, then that is not taken into account. Clear? Then you know the projectile is launched with the velocity v0, makes an angle theta naught, like that. So it is launched with the velocity v0 and then it forms an angle theta naught. Is it clear? Then what it says, after the object has been projected, the acceleration acting on it is that due to gravity which is directed vertically downwards, right or not? So here if it starts, here the acceleration begins, okay, then it is constant right now. Now what happens if the object fly here in an air, it is flying, right? So it has acceleration vertically, here the acceleration vertically downwards. Why? Due to gravity. Gravity pulls the object, right or not? Is it clear? So towards the ground. So if the gravity acts towards the ground, we are taking that as plus g. If you throw like this, here the ball is racing. Here the gravity acts against, I mean, the action is against the gravity. So the gravity will be minus G here. So here it is plus G. So anyways, so the vertical acceleration might be plus G or minus G, whatever it might be. So based on the position where the ball is. Okay. So here the acceleration acts vertically downwards. Is it clear for you? Then totally we are taking the acceleration along the x-axis will be 0 always, because we are considering along the ground the gravity is constant. Only it varies when height occurs, right? So it is constant elsewhere, so that we are taking acceleration along the x-axis is 0. There is no acceleration. Okay? Then Ay only minus G. Clear? So vertical acceleration. Then there are two components, you know. If there is a vector, if this is a velocity vector, so I will show you the picture. Here you can see now the object is projected from here. Okay, and then this is the initial velocity we have taken, and then it forms an angle of theta naught. This blue color only shows the trace of an object, okay, or the trajectory of an object, projectile. Okay, then so you can able to split this into two components, right or not? For that you have to construct a perpendicular to the x-axis to the y-axis. Then it forms a right angle triangle, you know. Then this forms a hypotenuse side. This will be the angles opposite, so opposite side. So this will be adjacent side. Since this is adjacent side, it will be cos theta, right? Since it is opposite side, it will be sin theta. So here and here are same. Here and here are same, equal and opposite, right? So that we are considering this as Vx component. What is V naught x component? It is V naught cos theta naught. We are talking about the initial position, so that this naught is there, 0 is there. Okay. So what is V naught y component? So V naught sin theta naught. Is it clear? Acceleration acting downwards definitely. So it is minus G, J cap, because it is along the y axis. Is it clear? Okay. Then if we take the initial position, yeah. So we are taking this as an origin, right? X and y axis meet at origin. So 0, 0. So x naught is 0, y naught also 0 here. Okay. Then what is the first equations of motion? Here also we are using simple equation of motion only we are using. So don't worry about that. But you need to understand the scenario. So this is the scenario. Initially we are considering V naught as the initial velocity. It is now resolved into two components. So two velocities we are seeing, as well as two acceleration also. One acceleration along the horizontal one, that is along the x-axis is 0. Another one we are taking y-axis, that is ay or minus g, because it is going to hit the ground, right? The gravity pulls. Then we'll see here. So what is this V naught x? So what is the first equation it says about? So where it comes this equation? Any idea? S is equal to ut plus, one second. S equal to, start writing right now. This is the first case. Starting point, you are taking x naught is equal to y naught is equal to 0, 0, 0. So what is the equation? Second equation of motion you are taking. S is equal to ut plus half at square. Since here instead of s we are taking x minus x naught, right? Initial position to final position, the object's position. Then u will be here. First we are taking u naught x component. Okay, u naught x component, then plus u naught will be v naught here. We are taking as v naught only, right? V naught x component. What about this along x axis? This a will be ax, right? Got it? Clear? A will be ax. Here we are writing x component. In a bracket you can write it is x component. Is it clear for you? Yeah. ut. Here it is. T is there. Correct. V naught x into t is there. Then, so what is the x naught here? What is the value of x naught? X naught will be 0, right? So it is 0 here. Ax also 0, right? Clear, Amma? So the total component will be 0. This term will be 0. Then what is the resultant? X is equal to V naught Ax times t. So what is V naught x? That is equal to V naught cos theta naught into t. That is the x component. Is it clear? Purida, is it clear for you? Balaji? Then, so what is this y? Next, you can be able to write as a y component. What is y component right now? In your book, you have to write in your notebook. What is y component? Start writing along with me. These are all not given in your book. Otherwise, you have to mug it up. That's it. Right? Don't mug it up. The derivation should be learned properly. Make it. So y minus y naught is equal to what? Here it will be v naught y times t plus half a y t square, right? So what is y naught? Y naught also 0, right? V naught y will be v naught sin theta naught times t plus what is a y now? Minus g, right? So this will be minus g we are writing minus half g t square. So let this be first equation. Put like a first equation and second equation. Are you writing? Make it fast. So second equation of motion you are taking, that is for the displacement, right? So you have taken for the displacement. You first freeze the displacement equation right now, that is x component and y component. All these projectile dealt with two components since it is in a plane, right? The action is done in a plane. So then we'll move on to the velocity. After the displacement, velocity will be there, right? Finished? All of you? Okay. So we'll move on to the next one. So what is the velocity equations you understand from it? What might be the velocity equation?
V minus u is equal to a.
Yeah, so or v equal to u plus a like that. Okay, so here we are writing. So what is here? It will be like the velocity equation. So here v equal to u plus at. So in the place of v, we can write vx component. First one x component. U can be written as v naught ax, right? Initial velocity. V naught ax plus what is this? Axt. You know ax will be 0. So vx is equal to v naught x will be cos theta naught, right? V naught cos theta naught. Is it clear? So this will be the third equation we can write. Same way Vy. What is Vy here? Vy equal to V naught y plus Ayt. Right? So Vy equal to V naught sin theta naught minus g. Right? So this is the fourth equation. Is it clear for you? So two coordinates we found for both displacement and velocity, right? So where the maximum height achieved, we are going to see that. Okay? So at the maximum height, have you written all these things? So at the maximum height, what might be the velocity? If the particle reaches maximum height, like this, maximum height, and then it falls down, it hits the ground like this. It is the maximum height. At the maximum height, you have to resolve into two components of the velocity, right? So what might be the velocity here? Here you have taken velocity and it is converted into two. Resolved into two. Suppose if you are taken here, the velocity also resolved into two components, horizontal component, vertical component. If you take the velocity here, it may not be resolved into two, right? Is it clear or not? Only along x-axis there might be velocity. What about the y-axis velocity? At the maximum height, Vy is 0. So at the maximum height, the velocity might be 0. Okay? Keep in your mind, maximum height, always, if the ball is moving, the ball is flying in an air. So at this maximum height, the ball stops for a while and then it falls down. Okay, so at the maximum height, the maximum velocity is 0. Okay? Then you can apply it. Okay? And then you know the direction, right? You must know the direction also. You know, this is the resultant, right? V0 is like a resultant. So if it is like a resultant, what is that? The resultant should contain its magnitude as well as its direction. If you want to check its direction, then you need to put a formula of tan theta formula. You know, right? So tan theta is equal to Vy by Vx. That is, what is Vy? Opposite by adjacent. Okay? So for theta is here, theta naught. This is Vy or V naught y. This is V naught x, right? Okay, in general, if you want to write, it is initial position. In general, average, if you want to write, then this tan theta naught will be tan theta, like that we can take. And then tan theta is equal to, what is this? Opposite side, Vy by adjacent side, Vx. So what is theta now? Tan inverse of, you can bring this tan to the right side, it will be tan inverse of Vy by Vx. Is it clear? So that is what given in your book. It talks about the direction. So based on this theta only, the direction varies. If theta decreases, then the direction will be like this, right? Clear? If theta increases, then the direction will be like this, right? So the direction varies based on the theta value. If you want to find theta, that should be around tan inverse of Vy component by Vx component. So that theta will be 0 at maximum height if you put Vy is equal to 0. So at the maximum height, theta also 0, right? It is parallel to x-axis. So theta also 0. Then we are going to find the equation of a path of a projectile. You know, the path of a projectile is like a parabola. We are going to confirm, okay, that as a parabola. If it is a parabola, definitely it is a kind of quadratic equation. Right or not? Okay, if it is a parabola, definitely the equation should be in a quadratic level. Okay, so we are going to write the equation like this. So how we can write this equation? Any guess? Any guess? Where theta naught comes? This is tan theta naught, right? So how it comes? If you divide this and this, Vy by Vx, then only tan theta naught comes, right? Okay? If you divide y and x, then only it will be like. So how this equation arrives? Guess. Actually, nothing is revealed in it, right? What they said. This can be seen by eliminating the time between the expressions of x and y as given in equation 4.38. So these two equations you have written as 1 and 2, right? From that they are eliminating t. Okay, so can we do that right now? You better write in your notebook from equation 1 and 2. From equation 1 and 2, we are eliminating t. Okay, so what is the t now? So what is the first equation? Tell me now. What is the first equation you have written? X is equal to v naught cos theta naught into t, right? So what is t here? X by v naught cos theta naught. Got it? Okay. Substitute this. This is the first equation. Substitute this in equation 2. Then only you can able to eliminate t in it. What is the second equation? Y equal to v naught sin theta naught t minus half gt square. Right? Correct? So in this you are going to substitute instead of t, that is x by cos v naught cos theta naught. Got it? X by v naught cos theta naught minus half into g into x square by v naught square cos square theta naught. Since it is t square, right? Got it? Then, or else you can simply write x square by v naught cos theta naught the whole square. So here it conveys clearly, right? So v naught gets cancelled. What is sin theta naught by cos theta naught? Tan theta naught. X minus, here it will be g by 2 times v naught cos theta naught the whole square into x square. Okay. So it is a kind of quadratic equation which is of the form this one, right? Some terms in x and some coefficients into x square. Got it? Where a and b are the coefficients. So it is like a parabola. It is a parabolic equation. So we are confirming from the equation the trajectory of a projectile, or the path of a projectile is a parabola. Is it clear? Okay, since it is following the quadratic equation, it is a parabola, we are confirming. Okay, is it clear? Are you writing? So it is not given in your book properly, all the intermediate steps are skipped. Okay, so you need to copy this. It's very useful for you, otherwise always you will be saying physics is very tough, boring. Huh? Okay, you have to follow all these steps, then it is easy, right? Shall we move on to the next one? Completed? So this is what it clearly shows the path of a projectile. I've already explained you. Okay, so the particle may fly in an air like this. Is it clear? So it shows like this. Here the particle hits the ground. So you have to take every velocity in downward position like this. Clear, ma? Here it is upward, here it is downward like. Got it? So here the velocity will be negative, right? So negative v naught y j vector. So downwards of the y axis. So that is negative. So here negative velocity, negative vy we have taken. So what they confirm, if the object hits the ground, it may causes some erosion in a soil. So the velocity acts downwards only. That vy is negative here. Okay. Okay, then we'll see maximum height, time of maximum height. So first, in the first case, what did you see? You are showing that the path of a projectile is a parabola. Okay, by eliminating t. So you are constructing an equation in terms of y is equal to ax plus bx square. Like that you have constructed an equation, derived an equation. Next we are going to find out the time. What is the maximum time, okay, the projectile requires to hit the ground? Okay, so total maximum height, sorry, time of maximum height is first determined. So until this one, the time is found until the maximum height is reached. Okay, time of maximum height. The object is flying, okay, it is projected. When it reaches the maximum height, what will be the time? That means half of the time is calculated right now. Okay, so in the total journey of a projectile, you are calculating first the half of the time. Okay, at the maximum height. Since you know at the maximum height the velocity will be 0. That is the hint we are taking. Okay, so the heading itself has the meaning maximum height, the velocity will be 0, right? Okay, so you are substituting, you are taking Vy alone and then equating this Vy to 0 here. And then find out maximum time. That's it. Very simple, easy, right? Correct now? Clear? So Vy, you are putting Vy as 0. So this is the equation of a velocity. Here you are putting maximum time. Vy is 0. At the maximum height, Vy is 0. So sin theta naught minus g Tm. In order to find Tm, so you can write like this. Got it? Bring this gTm to this side. So Tm, T maximum height is equal to V naught sin theta naught by g. Is it clear? So that is the maximum height. Next, total time or the time of flight fully. Total time will be 2 times, right? Right or not? So initially you found the time of maximum height. The time of maximum height is until half time we can say. So that means half path it is completed. Okay, if it completes full path, the total time of flight will be calculated by multiplying 2. That's it. Okay. Similarly, we can able to find out the maximum height of a projectile also. So height means definitely along the y-axis, the displacement. That is the height. The displacement of a projectile. Right? Correct or not? Okay, we can calculate the time by using a time of maximum height by using the velocity equation. Since at the maximum height we are having only one hint, you might be confusing why we are taking all these equations. So when these equations will be used, right? So for maximum height the velocity Vy is 0. That is the hint we are having. Based on that we can easily find out the time period. Okay. Next one, at the maximum height we are going to find the maximum height. Maximum height means it talks about along the y-axis. So we can take height means it's like a distance, displacement. Okay. Then what is the first displacement? Y equals, second equation. You have written, right? Y equal to this one. What is the equation you wrote? Yeah, what is that? Y equal to V naught sin theta naught into T minus half G T square, right? So here we are considering the maximum height, right? So at the maximum height, the time reached is maximum time, right? That means the time of maximum height you are writing. It's not a maximum time, the time of maximum height. You need to substitute Tm here. Okay. What is Tm? Or it is recorded as maximum height. So it is height suffix m. It will be V naught sin theta naught. What is Tm da? You have calculated half of this, right? V naught sin theta naught by G. Then minus half G. What is Tm square? V naught sin theta naught by G the whole square. Is it clear for you, this one? Clear or not? Okay. This is maximum height. So you can substitute everything and find out from this. Here also V naught square sin square theta. Right? Here also V naught square sin square theta. But here G square is available. Here only G is available. You can get the maximum thing, like. Okay? So how can you get this maximum thing here? For example, so if you take V naught square sin square theta outside. V naught sin theta not the whole square outside, right? Then inside will be 1 by G minus this G and G gets cancelled, right? 1 G gets cancelled. Clear? So 1 by G minus 1 by half G, right? 1 by 2 G. Is it clear? So 1 minus half will be half. So it is half. Clear or not? Can you able to do, or you want me to do? So you have to consider. So both the side V naught square sin or V naught sin theta naught the whole square, right? If you multiply. If you take this outside, then the first term carries 1 by G. In the second term, this G can be G square. So 1 G gets cancelled. So you have taken minus 1 by 2G. Yes. Padichitiya? Finished?
No. All right, yes, person.
Do you have doubts? No? Better ask him. You need to write the particular tabular column. So I taught him how to handle all the tabular columns for the 4 lessons. You have to write serial number, name, reactant side, in the presence of, and then product side. So start write that for the preparation as well as the chemical reactions. I'll be coming. There. So what is the resultant here? V naught sin square theta. What is this? 1 by G minus half 1 by G. So if you take an LCM, it will be 1 by 2 G. Okay? Then V naught square sin square theta naught by 2G. So this is the maximum height, H max. Okay? Instead of M, you can introduce H max like that. Is it clear for you? Take down this. Finished? So keep in your mind, so what all you have calculated, don't get confused which equation you can able to use it, okay? So you just, you have to know the meaning. So what are all the things you are going to find out. Based on that, you can use any clues to select the equations, okay? Is it clear? Shall we move on to the next? So this is the maximum height, okay? Then horizontal range. So what is that horizontal range? So this x distance, okay? How long it takes or how much distance it takes to hit the ground. Okay, in the play like javelin, in the sport like javelin, discus, right? The athlete throw that disc to the larger distance, right? So the maximum range. So the gunshot also takes place like that, right? It should reach the maximum distance, like. So what is the maximum range here? So, yeah, what we can do, what displacement we can take. For the maximum height, we took the displacement along y axis. For the maximum range,
X-axis.
the distance displacement along x axis. Clear? Can we take like that? So, what is the x axis formula? What is x?
X is equal to V naught cos.
So, x is equal to v naught cos theta naught
T.
into t. Okay? Here, for the maximum range, for a maximum height, we took Tm, the time period of maximum height. For the maximum range, it is the full time of flight. We should introduce time of flight here, right? In the place of t, it is time of flight. In the place of x, we can introduce r here. R is the maximum range. So that is the letter designated over here. You need not worry about the letters. You can use your own letter and then you can name it. So by using this, you can name here R as a maximum range. You need to label this. Okay? So what is this? R is equal to V naught cos theta naught TF. What is TF? 2 times of V naught sin theta into G. Is it clear for you? Then if you multiply this, so V naught into V naught, it will be V naught square. So 2 cos theta sin theta. So it looks like a sin 2 theta formula, right? 2 sin theta cos theta will be sin 2 theta. Forgot, right? Third lesson, third chapter, gone away from your mind. Like Kavya? Sanjay? Then, what is sin 2 theta formula?
2 cos theta sin.
Okay, is it clear for you? So it is a formula. Okay, ma? It's a trigonometric formula. You can keep in your mind. Okay, 2 sin theta cos theta will be sin 2 theta. Got it? Okay. So R is equal to V naught square sin 2 theta naught by G. In mathematics, you may know how it comes. How 2 sin theta cos theta will be sin 2 theta. There is some derivations over there. That is not at all needed here. You keep this in your mind like a formula. What is sin 2 theta?
2 of cos
2 cos theta sin theta or 2 sin theta cos theta, both are same. Then, so this is the maximum range. Is it clear for you? So, if an object, if a projectile wants to hit the ground in a maximum range, okay? So in your younger days, you might have, play like this, right? So all the children, all the kids, including myself, my mother, my grandmother, everyone, like if we throw a stone and then we play, right? We play like throwing a stone, okay? Maximum distance where it is hitting. So that is our target, right? We'll check with that. Okay, so likewise, if you want to know how much, if I throw in which angle, then it reaches the maximum range. Okay, the angle decides the maximum range, the direction as well as the maximum range, right or not? So we are going to discuss with that. If the range is maximum, that is R max, when the sin theta will be maximum, let me know. When the sin theta will be maximum. You know sin values, right? Everything I taught you in math. What is the maximum value of sin theta?
1.
1. For which angle it carries 1? 90 degrees. So sin 2 theta is here, right? Is equal to 90 degrees. Sorry, you are saying 1, right? So the maximum value. So maximum value of 1 is sin pi by 2, right? We can equate here. So 2 theta is equal to pi by 2. What is theta now? Pi by 4. What is pi by 4? 45 degree. Pi is 180. So 180 by 4 is 45 degree. Clear or not? So if you aim a projectile in a 45 degree angle, definitely it reaches the maximum range. Is it clear? If you put theta naught is equal to 45 degree, then sin theta will be 1. Then the R maximum will be V naught square by G. Is it clear for you? Until right now, the projectile is, I mean, you have studied maximum about the projectile or projectile motion. Okay, if an object is flying in the air, these are all the things it is associated with it. Okay, you are dividing both the velocity, displacement, and acceleration into two components. You are resolving that into two components, and then with that idea, you have derived maximum range, maximum height, okay, total time taken, everything. Is it clear? Done? Thank you.